Hello and welcome into the content video for lesson 17 for Precalculus 2. As I mentioned in the example video for 16, lesson 17 will be the last lesson that we have these videos for. If you're looking at the schedule for the semester, you see there's a lesson 18 and 19. There will not be videos for those sections. We will just address those in class with in-class lectures and some examples in class. But it's not going to be content, example videos, mastery sets, in-class assignments, all of that stuff. So this will be the last content video that you'll see this semester, and then the next video will be the last example video. This is a little bit longer of a section, as you'll see from the timestamp there. So let me share my document camera. This lesson is on vectors and dot product and angles between vectors and word problems with vectors. So quite a bit of content we're going to cover here. So first, if we're talking about vectors, let's get a definition here. So a vector in the plane is a line segment with an assigned direction. So think of this like maybe a fish swimming in the ocean. So we can say that the fish is swimming in a certain direction, and every hour it's going, 2 miles or something. So we can set stuff up like that where by notating this as a vector, we don't have to go through all that saying, oh, well, the fish is swimming, due north at 2 miles an hour. We don't have to do all that verbiage. We can just notate it as a vector, and that vector will tell us that the fish is swimming due north at 2 miles an hour. And so a way to visualize this or think about it is think of a vector as representing displacement. So the fish starts at some point, it moves its prescribed distance over a certain amount of time in a certain direction. So we have vectors in the coordinate plane. And so let's say that we're starting at some point and the vector is pointing in some other direction here. We have our horizontal displacement or our horizontal component. Let's call it A. And then our vertical displacement or component, we'll call that B. And so we can notate this with a vector by doing the following. So to go from an initial point to the terminal point, we move A units left or right, depending if it's positive or negative, and B units up or down. And we denote this by the following. So V, our vector, and our vector can have any name. It could be U, it could be V, W, whatever. We'll put V for vector in this case. So V is equal to AB, and it has these sort of little arrows on the outside. So notice it's not parentheses, it's not brackets like we've been using for things in the past. It's these little arrows. And when it has these little arrows, that's telling us, hey, this is a vector. And from our initial point, we move A units left or right, B units up or down. Now, how long is this vector? So actually, I'm going to leave this here because we'll use this one we drew above. So magnitude of a vector. And as you can probably guess, it's the same formula that we've been using all semester long, which is what? Pythagorean theorem, our modulus, our radius, all of that. If I want to know this magnitude, and we denote this with like an absolute value symbol, so this means the magnitude of V. So if this is my vector V up top here, how long is this? Well, it's what? The square root of A squared plus B squared. Again, it's the same formula that we've been using all semester long. Pythagorean theorem, whether we call it magnitude of a vector, modulus, radius, hypotenuse, etc. It's always the same formula, right? So we have some special vectors. So we have the following. A vector of length 1 is called, well, let's see. If I have a circle with radius 1, it's called a unit circle. So if I have a vector of length 1, it's called a unit vector. 1 unit long vector. And so two useful unit vectors are denoted as I and J, where we have the following. I is equal to 1 unit to the right. Now, of course, if I had minus I, that would be 1 unit to the left. And J is my vertical, so that's 0 units left or right, 1 unit up. And again, if I had a minus sign, it would just tell me how many units up or down. And any vector can be expressed in terms of I and J as follows. So if I have some vector with its components A and B, so A units left or right, B units up or down, this can also be written as AI plus BJ. So A units left or right, B units up or down. Now, let me put a big in highlighter here, note. So if you are writing vectors in terms of I and j on WebAssign, on the homework, so let's see, so you have to use the I and j vector buttons on the drop down menu on the right side there. So where you find like your square roots and your whatever pies and thetas and all that stuff, there's a tab that says vectors, and when you open that up, you're going to see one button with like a bold letter I and another button with a bold letter J. You have to use those buttons. If you just type I and J off the keyboard, it's not going to understand your answer. So you have to use those buttons when you're notating unit vectors, or well, when you're notating vectors in terms of I and J. All right. So that's sort of our background on vectors. Now, where this is going to come into play for you guys, anyhow, is our word problems. So vector word problems. So I'm going to try to go through the verbiage of what is on these problems and then what does it mean. So for our purposes, we have some object impacted by some force. So this could be a plane flying against the wind. It could be a swimmer with the current of a river. So they're trying to swim across a river and there's a current. It could be a boat or a fish or something like that. And again, I guess a current, like an ocean current, some sort of force of the water moving it in a different direction. So in reality, like nothing is still, right? Like you don't, if you're in a boat out on, the Pacific Ocean, even though you might think you're headed directly north, the current of the water is pushing you left or right from where you're headed. So in these problems, you are going to be asked essentially like 5 different pieces of information. And in these word problems, you are going to be using SOHCAHTOA frequently to figure out these values that you need. So the first thing that you're probably going to be asked is express the force. So it could be express the river, express the wind, express the ocean current. It could be whatever. Express the force as a vector. It could be in terms of I or J. It could be in terms of components, like with the little arrows. But that's just the force by itself. So that one's pretty straightforward. It'll say express the whatever wind velocity as a vector. I should probably put velocity. So express the force velocity as a vector. Now the next one, and I don't know why it's worded this way, but it is. It'll say express the velocity of the object, so the plane, the swimmer, the boat, the fish, whatever. Express velocity of the object relative to the force. So express the velocity of the plane relative to the air. Express the velocity of the boat relative to the water, etc. And all this means, and again, I don't know why it's worded like this, and they don't just make it as simple as possible. This just means the velocity of the object by itself. So pretend there's no wind, pretend there's no ocean current. If this boat was sailing in a vacuum in some water and the water never moved, it's obviously not going to move left or right, up or down. So it's just the velocity of the object by itself. Once you have those two, the next thing it'll say is express the true velocity of the object. So it might say whatever, express the true velocity of the jet, express the true velocity of the swimmer. And what this means is you're going to add the vector you found in number 1 plus the vector you found in number 2. That's it. Just add them together. That gives you true velocity. Then it's going to ask you, find the true speed. And what this means is the magnitude of the vector you found in number 3. So you see how this is all building on itself. We find the velocity of the, let's do the jet and wind. We find the velocity of the wind as a vector. We find the velocity of the plane as a vector. We add them together to get true velocity of the plane. Now we want the true speed of the plane, so we take the magnitude. So maybe the plane is flying due east, but there's a headwind going due west. If the plane's going on its, dashboard there at 500 miles an hour, well, it's not really going 500 miles an hour because the wind is slowing it down. That's our true speed. And then lastly, find the true direction. And this is going to be SOHCAHTOA with vector number 3 that we found here. So if it's telling me whatever, 3 units to the right and 4 units up, well, then I do SOHCAHTOA to find that angle to give me the true direction. So that's how you're going to do these word problems. So that's our vectors, and we're going to look at another concept of vectors, but that's our vectors, that's our notation, that's the word problems. We now have something called the dot product. So let me give you the definition of this. If U is A1, B1, and V is A2, B2, so if those guys are vectors, their dot product which is notated U dot V, is defined by so U dot V, this I guess probably shouldn't make it an open circle. It's a close, it's a dot. So u dot v is equal to, so what I'm going to do here is multiply the first two values in these vectors. So a1, a2, and add it to the product of the second two. Now, again, in this formula, it's called A1, A2, B1, B2, but that's just what it called. This could be like A1, A2, B1, B2. The key is that you're multiplying the first values and adding it to the multiplication of the second value. So B1, B2. And note, the dot product is not a vector. So you do not get another vector back. It is a real number. So an actual number, integer, a fraction, well, probably not a fraction, but it's a real number. So you're not getting a vector back when you do dot product. We can use this dot product if we have two vectors and we want to know the angle between. So if I want the angle between vectors, I have the following. This is where we have to be careful. Cosine of theta. So if theta is the angle between, then cosine of that theta is the dot product u dot v divided by the magnitude of u times the magnitude of v. So once I get a number here, that doesn't mean that's the angle. Cosine of theta is that number. So I would have to do what? I would have to do cosine inverse of whatever number that is to get the actual theta. So if you want to write that down so you don't forget, theta is actually cosine inverse of u dot v and product of u, product of v. And then just as a note, we always write theta between 0 and 180. So I wouldn't say like the angle between two vectors is 330 degrees. No, the angle is 30 degrees. So don't go over 180 when you're doing that. All right. Well, that's it. I know it's a lot of content, a lot of definitions, but come on back. We will look at a bunch of examples using these different formulas and concepts. And then that will wrap up our material for the semester, for the videos, 2 in-class lessons. See you in the example video.